Hello guys, so today I'm gonna show you how to actually write something like this, like a graph, directed graph, into memory in C#. And to do so, let's start with a new project. Let's call it graph theory, long-term support.NET 6, okay. And I already have it prepared as an input, so input needs to look something like this, which corresponds to the image, if you can see. So meaning A to B is distance 5, A to C is distance 1, C to G is distance 1, and so on. Okay, so in this tutorial we will just take this in and print it out as our own classes. You will see what I mean. Okay, so first enable Hackerman mode, which is console dot foreground color equals console color green. Okay, and now let's add some classes. We'll put it in the models folder, and let's add a class named node. Okay, node is these circles, and these connections are called edges. Okay, and then add a class edge. Okay, and let's start up with the input. So first thing is number of edges. Let's call it number of edges equals console dot read line, not dot length, and by default let's say it's 0. Okay, or actually number 0. Now let's first int dot parse something like this. Okay, that's fine. Then we have the nodes A and M. Okay, start node equals, let's say, car.parse console.readline. But I don't like this. Why? Because we don't need it to be character. We have our class node now. Let's make it public. I don't know why they are forcing internal now. I know it's better. It's inside, stays inside the assembly you're working with, but anyways. So instead of parsing with char, let's make our own static method, public static method, which will return node, and let's call it parse. Okay, and in here we need to send a string to parse input. Okay, and let's return a new node. Who knows what will be there, but we know that it has a public string name. Okay, and here we will just put the name equals input. That's it. And to not repeat the nodes with the same name and the same actually with the same name, how we can do that? We need to add some sort of a list or a hash set which will keep unicate values in itself. So I will do exactly that, and I will make it public static hash set not string but node, hash set of nodes equals new. I think this is a new C# syntax. Yeah, works nice. Okay, so now we will change the code a bit, and we will also just note that add this existing node. So how can we be sure that they will look at it differently in this hash set? So we need to identify it by something, and let's say that something is name. Okay, so to do so, hash set uses two important methods, that is get hash code and equals. So in get hash code, let's return name.getHashCode. So now we are already by having the same hash code for the two same nodes, and we also wanna compare it to the other object. So now if object that other is node, some node, and we will just return if node is node.name is equal to this.name. Okay, and return false otherwise. That's it. So in this way we have okay, I increased the font a bit just for you guys. So this way, when you put a new node into hash set with the same name, it will not be added. It will recognize it's the same node. So this one will not end up in all of the nodes that we are putting it. Okay, so this way we only miss one thing. We wanna show it to the user somehow, and I will use the string for that, and some custom string. Basically we will print out the name and some identifier that it is actually a node. Node is a circle, so let's put like this circle, like letter O as a circle. Okay, and that's basically it, I think, for the node. So let's try this out, but let's also test. How we will test this is simple. So let's display number of edges, and let's display start node. Okay, they will call toString on the any object in the writeLight method. So we will be sure if we see this, then we are sure it's working properly. Okay, so number 13, A, and that's it. So number 13 and A, but it's not showing actually our. That's weird. Oh, we didn't parse it with a node. We need to use our own node from our graph theory models, and let's try again. 13 and A. Okay, you see now we know it's a class node. To test it out, let's also start with the end node, and let's make a default value B, but let's put end node here as well. Let's see, 13 A B. See, everything works. But what if we have a 13 A A? See, I don't know how I can make you trust me, but it is actually the reference to the same object. So okay, we could do something like this in the end. Console write line start node equals end node. Okay, even though oh, that's false. Okay, maybe that's because I didn't call the proper equals. because that's a special operator, you know. I didn't override that one. I override get hash code and equals, which is enough for the hash set. Okay, sorry. Let's try again with 13 A. And now it's true. See? So we are done with the nodes, and now the edges. So the edges, we have how many of them? Well, number of edges. And now let's make the same thing as we have here. For the nodes, let's create a set for the edges. Okay, edges. Okay, let's also be consistent and make it public. Okay, so now edge dot edges dot add edge dot parse. Okay, so now we need this method to parse the edge. Actually, we don't need to do this. We don't need to access that hash set from there at all. We can do this internally while parsing. So let's see if this can help us. Yeah, okay. String doesn't need to be nullable. Let's just use a normal string. Let's be consistent and public, and let's make this return an edge. Parse string input again. But what do we have in input now? We have 3 space separated values. Okay, so let's say var parts equals input dot split, and not by the dot but by the empty space. Okay, so what are the first 2 parts? Well, they are nodes. Let's parse the nodes then. So var node 1 equals node dot parse. Okay, there was something here. Yeah, this new intelligence is amazing actually. Okay, that's it. Yeah. So node 1, node 2, and the last one is distance. Okay, but let's define the edge a bit. So the edge needs to have a node, which is node 1, and it also needs to have a node 2, but it also needs to have a distance. Okay, nice. And let's say var edge equals new edge, and let's say distance equals int dot parse parts 2. Okay, and the node 1 is node 1, and node 2 is node 2. Okay, so this way we are parsing the edges. But we said we wanna add them into this collection, so edges dot add edge, and that's it. I will not check for the equality of these, so honestly this can just be a list. Why? Because we trust the maker of this graph, that he didn't lie to us, that he didn't give us more of the same edges. So for that reason this can actually be just a simple list. Okay, and there is one more thing. So if we want to move through this graph, our nodes should also have connection to their own edges. So how can we do that? Well, we can add public list edges to each node, and here we only just need node 1 edges.add and this edge here that we made, and that's it. That's almost it. Almost everything is done, and we now just wanna show this edge on the screen somehow. Okay, let's say it's that connected to the other node, and the distance between them is something here. So distance here node 1 and here node 2. Okay, and I'm pretty sure this is it. This is how you can easily parse your input from graph theory into your nodes and edges models. Okay, so let's only thing left is to print out the edges. Just a second. Okay, so console write line, and let's use string.join. So this method you can actually with string.join. Okay, string.join. You can simply, without using any for loop or anything, you can join multiple lines into one with a separator for them, and it works fine. It doesn't add an extra separator at the end, but only in the middle parts. And what do we wanna do now? Well, we wanna do edge.edges as a printout, and now we can use full sample. Okay, object reference not set to instance nodes edges got null. So this was null. So that could mean what if we made it read only? Will it then again be the same problem? Nodes edges get return null. Why can't we access our edges? Let's try again. Again the same issue. I did not have this issue last time, but let's see how can we fix this easily, like in a clean way. We could add static constructor static edge, in which this public list of edges will get initialized, and we can make it read only then. But let's put it here and like this. Now it should work. So why it should work? Because the static constructor gets called first before any of the static stuff in this class. So let's test that out. Let's see if I'm correct. Oh, again edges node. Oh, node that edges got. Oh my god. So I think we were fine. We were actually fine, completely fine. We don't need to do anything here. The node is the issue. Yeah, sorry. Equals new list of edges. Okay. And this can be private set, because we only set it here privately. Okay, let's try again. And that's it. As you can see, Let me just separate the input so it's more readable. Let's do something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of these, test, 10 of these, okay? Okay, okay. Well, as you can see, there are 13 inputs. First and the second nodes are here. The connection between the nodes, everything is working as we wanted it to work. We can also add something else. We can copy this line, but instead of edges, we can say list us all the nodes, and we can use the comma separator. And let's try that. And as you can see, here are all the nodes as well. Node O, M, B, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 11, 12, 13, right? Okay, so let's see in the image. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, that's it. We got ourselves the nodes and edges. We got ourselves a graph in memory. Now we can do some algorithms with it, like searching for closest path, like in the image, closest weighted path. 5 plus 3 plus 2 plus 1 plus 3 is actually the shortest path from this point to this point. And that's for another video. So hope you guys enjoyed this. Thank you and see you next time. Bye.